Hello, welcome to this video on problem solving and programming. Problem solving, what I plan on doing here today is to solve a couple of just sort of simple logic problems in Java. And really, Java doesn't really matter here. They're simple if statements. We're going to use some simple logic. But what this video is really about is problem solving. Problem solving is one of those fundamental pieces of programming that a lot of experts kind of gloss over because it's so second nature to us. And a lot of people just starting out programming or starting out learning how to program really struggle with and don't know how to approach necessarily. I think that a lot of people, for some people, this may come as a little bit of second nature. But there's a lot of people that are visual learners or learn in a different way than just sort of robotic machine learning that do struggle with this a little bit. I see this a lot with people that are very into graphic design or very into visual type of arts or work and have a hard time breaking down sort of statements into step-by-step pieces. I think that there are some people that think in step-by-step and there are other people that think holistically. They want to sort of see a solution or a problem in its entirety and be able to solve it all at once. And sadly, that is something that does not translate to programming. But you can learn that. It is a skill that you can learn, problem solving, to be able to take a problem in English, break it down into steps, and then be able to solve that in code. So we're going to look at that today. Just as a quick thing, what I'm going to be doing is going on CodingBat here, codingbat.com, and taking a look at some of their problems and really working through them and trying to figure out how to solve these. What is my thought process as I go through these? And I'll try and break that down as step by step as I can. I've been programming for over 20 years, and so that sort of step-by-step thinking is actually hard for me. Once you reach a certain level, you know, if you go ask an Olympic skier how to ski, oftentimes they are very bad teachers because they don't even know what they're doing. It's very hard for an expert to sort of come back down to a level of, okay, what is my actual thought process here instead of just working on instincts. But I'm going to do my best. And we're going to look at a couple of problems here that are just basic logic problems, just using if statements and some simple logic operators. So we're going to be taking a look at problems that just use if statements. So if, and then some condition within the parentheses. If is always followed by parentheses, and what is in there is basically being looked at as if this is true, we are going to run code wrapped in curly brackets after it. So we're going to look at some of those. We're going to join some of these with two ampersands, which means and. So both conditions have to match before we run the if statement in something like this. If A is less than or equal to 10 and B is greater than or equal to 20. So we can join up these logic statements with an and. We can also join them up with an or, which are two vertical bars or pipes. That's the key over the enter key. And we can look at this as if we rewrote this with two pipes here instead, that if A is less than or equal to 10, or if B is greater than or equal to 20. So we can take either one. If either one is true, then we'll go ahead and run the statements. And also there's a not in here that will negate a certain logic statement. Basically reverse it from being true to being false. So the first one I'm going to look at, these are pretty simple problems, but they really do pinpoint a lot of this problem solving that you sort of have to walk through, especially if you've never really programmed before. So this is the problem called sumDouble. Given two int values, so we're going to be getting two numbers here, return their sum, which is basically just adding them together. Unless the two values are the same, then we're going to return double their sum. So in the examples here, if we get a 1 and a 2, we should be returning 3. If we get a 2 and a 3, we should be returning 5. If we get two 2s, we should be returning double their sum, which is 8. So knowing that, the first thing I always do is sort of look at these problems and say, okay, what, you know, are there some different avenues here, and what's the simplest avenue to solve first? So I'm not going to try and solve the whole thing all at once. And so if you're someone that sort of looks at this and tries to formulate an entire solution in your head right off the bat, I would recommend not doing that, especially if you're a novice programmer. This is something, and novice not as in insulting, but as in you're just starting programming. This is something that you don't want to try and jump to right from the beginning. Instead, solve an easier problem. So there are a couple of problems in here, but we can just pick one of these things to solve. And once we solve that, then we can go back and look at some of the other things. So first, there is a simple statement of given two integer values, which one is going to come in A, one is going to come in B, return their sum. Okay, so they want me to return the sum. Well, first I need to get the sum. Or I could just say that. So let's do return A plus B. That returns the sum, right? And if I run this, I can actually see that a lot of the test passed for this. If I get a 1 and a 2, I return 3. If I get a 2 and a 3, I return 5. There are a couple that fail, though, and that's when they're exactly the same. So I've already solved most of this problem. Just by solving a small chunk of the problem. So then it says, unless the two values are the same, then return double their sum. So here, obviously, I am going to be branching on two different paths. One path I have is if A and B are not the same. The other path is if A and B are the same. If I ever have two different paths, I want to run two different sets of code for basically two different conditions. That means I'm going to need an if statement. Also, this keyword unless kind of tells me that also. Unless is a trigger word for an if statement. So I'm going to come back in here and I'm going to solve this the most basic way that I can think of, which is I'm going to say if I'm going to go ahead and check for this condition. If two values are the same, so if A equals B, if A equals B, I want to return double the sum. And remember our parentheses because of order of operations. I want the addition to happen first, and then I want the doubling to happen. Now, if that's not true, if A does not equal B, then I'm going to have an else here, and that's where my original solution goes. Which is still completely valid here. And if I run this, I get them all correct, right? So the key, solve a smaller problem than the whole thing first. Then see how you can change that to solve the bigger problem. I also want to look at this a different way. So I'm going to delete all of this. And I could also read this as given two int values, return their sum. Unless the two values are the same, then return double their sum. In both of these problems that are sort of described here, sum is an important keyword. I still need the sum no matter what. So let me create a variable to hold the sum and then calculate that, because I'm going to need it no matter what. So let me just do it first. So I have the sum. Then if I'm reading this, so given two int values, return their sum. If the two values are the same, I want to double that. Either way, I want to return the sum, right? But if the two values are the same, I want to double it. So here I could also put in an if statement. If the two values are the same, then I want to double the sum. And finally, in either case, I want to return the sum. So this might make more sense to some of you as well. This is sort of solving, this is probably a cleaner way to solve it in the long run. Honestly, though, if you find a solution to something, go with it. Don't feel like you have to have the perfect solution or the cleanest solution. So this will also pass all those tests. So this might be a solution that makes more sense to you, or something that you were thinking about. Either one is good. So let's take a look at another problem. So here's a problem, sleepIn. So here we have a method where we're going to be returning a true or false, and in the parameters we'll be getting a true and false on whether it's a weekday or whether it's a vacation. So the parameter weekday is true if it's a weekday. The parameter vacation is true if we're on vacation. So that's really not part of the problem, that's just telling us what we're getting, right? So we can now pretty safely ignore that. Most of these make a lot of sense, right? Weekday is going to be true if it's a weekday. Vacation's true if it's a week, if we're on vacation. So instead, let's look here. We sleep in if it's not a weekday, or we're on vacation. And we return true if we sleep in. So first of all, to parse this out a little bit, we return true if we sleep in. So I can take this return true and put it wherever it says sleep in, right? We return true if it's not a weekday or we're on vacation. Now again, I can break this up into solving this in sort of two steps. The first one being that if we are on vacation, so if vacation equals true, if we're on vacation, we sleep in, right? So I can say if vacation is true, then I'm going to return true. We're sleeping in. We return true if we sleep in. Now, one thing I want to point out here is vacation is already a Boolean, right? So I actually don't need vacation equals true, because vacation will already be true. So if we're on vacation, return true. That also means that if it's not a weekday, we return true. So if not a weekday, we're going to return true. So if we're on vacation, we return true. And once we return from a method, we're done. This stops execution right here. If vacation is true, we return true and we're finished. But if this isn't true, we're going to go to the next statement. And then we say, if it's not a weekday, we return true. Now, if both of those fail, we need another statement right here. What do we want to happen if neither of those is true? We want to return false. And if I run that, it passes the test. So this is probably the most broken out version of a solution to this problem. We can see very clearly that we sleep in if it's not a weekday or we're on vacation. So if we're on vacation, we sleep in. If it's not a weekday, we sleep in. Otherwise, we don't sleep in. And so this is a pretty broken out example of this. But you might also be thinking that we have an or in here. Couldn't we join these with an or? Actually, we can. If you ever have two if statements that have the same body, one right after the other, then that typically means that their condition can be joined with an or. So I should be able to take this, put it up here, separated by an or. And now I don't need this if statement at all. And still passes. So I should be able to read this much like English, or whatever language you speak, to be able to describe this in some way. So if we're on vacation or it's not a weekday, return true. We sleep in. And then I could put this in an else too if I wanted to. But really, if that doesn't happen, then we're going to return false. Now, we're returning true and false here, which means this is really just a Boolean. So to take this a step further, I don't even need the if statement, really. this condition, if this condition is true, it's going to return true. And if it's false, it's going to return false. Well, if this matches what we're returning, why don't we just have this be the return statement? So I could take all of this out, and instead of if, I can just say return. If I had a semicolon. So that is the simplest way of writing this statement or solving this problem. So solving these problems is all about really breaking these things down into steps and then writing code that sort of emphasizes that step. And again, that's not easy. This isn't something that is ingrained in a lot of people's heads. The key is just knowing if I have some sort of English statement, how to turn that into actual code on the end. And a lot of that is by breaking it down step by step. You don't have to solve this whole thing at once. And in fact, you wouldn't be able to. This is not something that you can just look at and immediately spit out the code for if you haven't done this kind of thing before. So you really need to sort of try and pick apart what is it that I'm trying to solve here, and what's the smallest piece I can solve first, and then add the other things on later. Hopefully that's helpful. I imagine I could do more of these videos if people are interested. But these are the kinds of things that I have seen some of my students struggle with when teaching programming.